Have you ever, looked at a really big software project, maybe a new Angular application you're planning, and just had that feeling of, okay, how do we actually build this so it doesn't just fall apart later?
Yeah, that scaling problem. It's real.
It is. It's a bit
Yeah.
like being given the plans for a huge skyscraper and
Uh-huh.
realizing, whoa, we need a serious strategy here for
Hmm.
every single beam, every floor, how all the systems connect.
Right.
You don't just need a map, you need a proper playbook,
Yeah.
a playbook for scaling successfully.
Absolutely. A clear plan.
Well, you're in luck today because that's exactly what we're doing. This is the deep dive, and we are diving deep, really deep, into Angular application and library architecture. And we're putting a laser focus on that exact challenge, building for scale. How do you actually engineer an Angular app so it can handle more complexity, more features, maybe even multiple teams working on it without turning into, well, a nightmare?
The dreaded spaghetti code.
Exactly. So that's our mission today. Our guide, our source material for this journey is this fantastic, really comprehensive course on Angular architecture.
It's a gold mine, really.
It is packed with practical strategies, real-world insights, best practices, all from a lead developer who's clearly navigated these waters many times. And our job, as always, is to pull out the most crucial nuggets for you, our listener. So whether you're prepping for a big architecture meeting, or maybe just trying to catch up on the latest in Angular, or you're just really curious about how to build these robust, scalable apps, well, this deep dive is for you.
And we are covering a lot of ground. This isn't just scratching the surface. We'll start right at the beginning. The foundational building blocks Angular gives you. Think components, services, the basics.
Fundamentals.
Exactly. But then we'll build on that, moving into the really advanced stuff. The strategies that are shaping how big enterprise apps are built today. We're talking things like micro frontends, module federation, and how monorepos fit in, especially using tools like Nex. These aren't just buzzwords. Understanding these is, well, critical for architecting apps at scale. Making those informed decisions. Just a quick note first, though, something the source mentions. It'll definitely help if you've got some familiarity with TypeScript and the basic Angular framework concepts already.
Right, the core stuff.
Yeah. And honestly, having experience with another programming language, even something completely different, can sometimes help grasp the bigger architectural ideas we'll discuss.
Makes sense. Different perspectives.
Exactly. So, okay, consider this the warm-up done. Let's properly get into it.
All right, let's start unpacking this. Before we even think about scaling, massive applications, what are the absolute basics? The ingredients Angular gives us just to build anything. And maybe even more importantly, is there like a core philosophy, a guiding principle we should always keep in mind, no matter how big the project gets?
That's the perfect place to start, absolutely. Because if that foundation isn't solid, everything else just gets way harder. The number one goal, the guiding star for pretty much any code-based architecture, and the source really hammers this home, is keep it simple, or, simple as possible anyway.
Right. Easier said than done sometimes.
Oh, absolutely. Simplicity is subjective, right? It depends on the project, the team. But if you're constantly asking, is this the simplest way? That principle alone acts like a guardrail. It stops you from adding complexity just for the sake of it.
Okay, so keep it simple.
Got it.
What about those basic building blocks then? What does Angular give us out of the box?
Right, the concrete pieces. There are really three main ones we need to get our heads around before we layer anything else on top. First up, historically, the main way Angular organized things are modules, or ng modules, technically.
Okay, the source calls them little boxes, which I quite like.
Yeah, it's a great analogy. They really are like containers. They're a primary way to group related things together, components, services, maybe even other modules.
So everything for a specific feature might go in one box.
Pretty much. Inside that module box, you explicitly say what it needs to import to work its dependencies and what it exports for other parts of the app to use.
Defining the boundaries.
Exactly. It's all about encapsulation, defining clear boundaries. And for years, modules were the way to organize Angular apps and libraries. Every app needed at least one root module, and bigger apps were split into lots of feature modules. It kind of forced a structured approach.
Okay, modules as organizational boxes. Makes sense. But you can't have an app without things the user actually sees. Components, right?
Absolutely. Components are totally central. You can't have an Angular UI without them. Their core job is to encapsulate the view, the HTML template, the CSS styling, and the TypeScript logic that controls how that piece of the UI behaves.
So they handle a specific bit of the screen, like a button or user profile card,
Exactly. It could be something small, like a button, or something complex, like a whole data grid, or even the layout for an entire page. Architecturally, they're where the user interaction happens. They display data, they react to clicks, typing, that sort of thing.
And presumably you can reuse them.
Oh, definitely. That's a huge part of it. Build a user profile card component once, use it wherever you need it, consistency, less code. It's fundamental.
Okay, modules for organization, components for the UI. What about the logic, the stuff happening behind the scenes? That brings us to services, right? They always feel like the workhorses.
They really are, and using them well is honestly a sign of a well-architected app. Services are where you put logic that isn't directly tied to a specific view.
Like what kind of logic?
All sorts. Could be your core business rules, maybe calculating shipping costs, validating a complex form. It could be data access, fetching data from an API, talking to local storage, handling WebSockets.
Ah, so keeping the data fetching out of the components.
Precisely. Or even just general utility stuff, you
Ye-
know, complex date formatting, interacting with a third-party library, all that goes into services. And the why is crucial, like you said. It's about separation of concerns. That's not just about being tidy.
Right. It has real benefits.
Huge benefits, especially as apps grow. Imagine you need to change how you get user data. And maybe switch API endpoints or move from REST to GraphQL.
Okay.
If that logic is scattered across 20 different components, it's a nightmare. But if it's all in one user service, you change it in one place.
Ah, I see. Much less risky.
Massively less risky. The source puts it perfectly. Services help keep applications and libraries easy to reason about as you scale, and they separate business logic from your application presentation. Your components stay clean, focused on the UI, while services handle the heavy lifting.
And you can use services inside other services too.
You can. That's where it gets really powerful. You can inject services into components, sure, but also into other services. So you can build up complex logic by composing smaller, focused services together, like Lego bricks for your application's logic.
Okay, that makes a lot of sense. Modules, components, services, the core toolkit.
Pretty much the foundational trio.
But you mentioned Angular evolves, right? And this is where things get really interesting, I think. The source talks a lot about a big shift. Standalone components. What's the deal with those? And why are people saying modern apps are ditching modules?
Yeah, this is probably the biggest architectural shift in Angular in recent years. Standalone components really changed the game in terms of simplicity and developer experience. The core change is this. With a standalone component, you define its dependencies, what it needs to import directly in the @component decorator.
So no need for an ng module to declare it anymore.
Exactly. You completely skip that ng module wrapper for the component itself. Same goes for standalone directives and pipes. It removes that layer of abstraction. And the source points out this can drastically reduce the abstraction and complexity. Fewer files, less boilerplate. The component becomes much more self-contained. You look at the decorator, you see exactly what it needs.
That sounds easier.
It often is. The course even mentions it gives Angular more of a React feel. In that sense, you're working directly with the UI unit. It can definitely speed things up, especially for smaller bits or when starting out.
Okay, if these simplify things that much,
Yeah.
why stick with modules at all?
Yeah.
Is it just legacy? Or are there still good reasons to use modules in new projects?
That's the million-dollar question, isn't it? And the source gives a really balanced, pragmatic answer. It's not black and white. The general advice is for quite small applications or for individual reusable UI bits, even in a large app, standalone often makes perfect sense. Less code, easier to manage. But for large page-driven applications, the source argues that modules still have a strong place. Why? Because they help abstract away a lot of the dependencies from the component itself.
How so?
Well, imagine a really complex page component, maybe the main component for your dashboard. It might need to import dozens of smaller components, directives, pipes, maybe several services.
Okay.
If all of that goes directly into the standalone components imports array in the decorator, that array can get huge. Really unwieldy, makes the component definition itself hard to read.
So the module acts like a container for all those imports.
Exactly. It lets you consolidate code into different module types, hiding some of that import complexity from the component itself. The module imports everything needed for that feature and then maybe just exports the main page component, keeps the component cleaner.
So it's a trade-off then. Simplicity versus organizational structure at scale.
Pretty much. The source acknowledges it often boils down to a stylistic choice based on the team, the project. But the goal is always that keeping things as simple as possible. And crucially, it's not an either. The source strongly advocates for a hybrid approach.
Ah, using both.
Absolutely. Use standalone where it makes sense, small components, shared UI bits. Use modules where they offer better organization, typically for larger feature-based or page-level concerns. That hybrid strategy is often the sweet spot.
Okay, that makes a lot of sense. Choose the right tool for the job. So, if modules are still very much relevant, especially these larger ones, what are these different types of modules the source talks about? It sounds like a way to categorize them.
It is exactly that. Having a clear classification helps structure things logically. The source breaks it down into 4 main types, each with a specific job.
Okay, lay them on me.
First, the root module, usually app module, generally just one per app. Its only job. Bootstrapping the application, kicking everything off. It imports other key modules and services needed right at the start. You keep it lean.
Got it. The entry point.
Precisely. Second, and probably the most common in large apps, feature modules. These group everything related to a specific feature. Think products module, orders module, user profile module in an e-commerce app.
So, one module per major section of the app.
Often, yes. Components, services, routes for that feature all live together. It promotes modularity, makes it easier for teams to own specific parts, and importantly, makes them suitable for lazy loading, which we'll get to.
Okay. Root, feature. What else?
Third, shared modules. Their whole purpose is to stop you repeating yourself. They collect and export common components, directives, pipes that are used in lots of different places.
Like a UI library module with buttons and input.
Exactly. Or maybe a utilities module with common formatting functions or logging services. You import the shared module wherever you need those things instead of importing individual pieces everywhere. DRY. Don't repeat yourself.
Right. Makes sense. And the last one?
The fourth type is the core module. Again, usually just one per app, often called core module. Its specific job is providing singleton services.
Singleton.
Yeah.
Meaning only one instance.
Exactly. Services that should only ever be created once in the entire application lifecycle. The classic example is an auth service for authentication.
Yeah.
You only want one instance managing the user's login state.
Yeah, definitely. You don't want multiple sources of truth for that.
Precisely. Or maybe a global error handler or a theme service. The core module provides these, and crucially, it should only be imported once, usually by the root module, to guarantee that singleton behavior.
Root, feature, shared, core. Okay, that's a really clear structure.
It provides a solid mental model for organizing even complex applications using modules.
And the source material actually shows a real-world example app using this hybrid approach, right? Combining modules and standalone components. How does that look in practice, like folder structure and all that?
Yeah, the example is really illuminating. It shows how these concepts work together pragmatically. Right away, in the CircApp folder, you see subfolders named core, features, and shared. So that conceptual separation is immediately visible in the structure.
Okay, mapping directly to the module types.
Exactly. But what's interesting is how the app itself starts. It doesn't actually use a root app module.
Oh, how does it bootstrap then?
It uses a root standalone component. The main.ts file calls bootstrap application directly with this standalone component. Shows the flexibility you have now.
Ah, embracing the newer standalone approach right at the root. Cool.
Yeah. And the pattern used within the app is key. The source suggests use modules for page-driven components loaded in routing context, and use standalone components for library shared components and for internal components within a feature.
Okay, break that down. Modules for pages.
Right. Think of major sections accessed via the router. In the example, there's a settings feature that's structured as a traditional settings module. It bundles the main settings component, maybe a setting service, its routes. It acts as the container for that whole page or section.
And the benefit is?
The module can handle importing all the necessary shared stuff, maybe common form elements, icons, whatever. The settings component itself stays cleaner, just focused on its job. The module acts as an organizational boundary and handles dependencies.
Okay. And standalone components for?
For the smaller pieces. Shared UI elements, definitely. But also for the internal components within a feature, even if the feature itself isn't wrapped in a module. The example has an article feature. It doesn't have a top-level article module. Instead, inside the article folder, you find subfolders like components.
For its own specific, non-reusable components.
Exactly. Standalone components used only within the article feature, like maybe an article metadata component or a comment list component. Then you'll have models for interfaces, services for article service, comment service, and crucially, a pages holder.
Pages within the feature.
Yeah, for different views or routes within that feature. Like articlesView.id might be article view page component, standalone. Articlesedit.id might be article edit page component, standalone. Each page is its own standalone component organized within that feature structure.
Wow, okay. So modules act as high-level wrappers for routed sections, hiding internal complexity, while features can internally use standalone components for granularity.
You've got it. The source highlights this, lets you hide your internal components and expose external components via modules. It creates clear APIs for your features.
And the structure recommendations reflect this.
Yep. Simple feature modules might just have the component, template, module, service files together. Larger features, especially those using standalone internally, get those subdirectories. Components, services, pages. It's a really flexible, powerful hybrid approach. Best of both worlds, really.
Okay, that structure makes a lot of sense. But let's shift gears a bit to performance. We've organized our code, but we don't want users waiting forever for it to load, especially on big apps.
Absolutely critical.
So what's the deal with lazy loading? Why is it so important when things start getting large?
Lazy loading is basically non-negotiable for performant large-scale apps. The core idea is simple. Don't load every module and or every component up front when you don't need to.
Load it only when the user actually goes there.
Exactly. Typically when they navigate to a specific route. Why load the entire admin section if the user is just browsing products?
Right. Makes sense. Reduces the initial download size.
Dramatically.
Okay.
Which means faster initial load times, less initial processing, a much snappier feel for the user starting out. It's huge for perceived performance. And this ties directly back to our architectural patterns. Using modules for those page-level features, perfect candidates for lazy loading.
Ah, so the router helps with this.
Absolutely. Angular's router is built for this. For standalone components, you use the load component property in your route definition. You point it to the component, and Angular fetches it only when that route is activated.
And for modules.
You use load children. This takes a dynamic import function that points to the module file. Angular then fetches the entire module's code bundle on demand. The example showed the settings module being lazy loaded. This way, you could see in the network tab it only loaded when navigating to settings.
So whether you're all in on standalone, all modules, or hybrid, you need a consistent, lazy loading strategy.
Consistency is key. You need to apply it strategically to get those performance wins across the board.
Okay, lazy loading for the user experience. But what about the developer experience? Waiting for builds, especially on big projects, can be painful.
Oh, tell me about it. Minutes sometimes.
Exactly. And this is where the source talks about something potentially game-changing in Angular 18, Vite-based bundling. What are Vite and SBuild, and why is this such a big deal?
This is huge. A massive leap forward for Angular developer productivity and even build efficiency. Let's break it down. First, SBuild. The source calls it an extremely fast bundler for the web. It's written in Go, which is super fast, and it just rips through bundling tasks incredibly quickly.
Okay, faster bundler. And Vite.
Vite is described as a new and improved version of Webpack. It's a modern build tool designed for speed, especially during development. And the key, Vite uses SBuild under the hood.
So that's where the speed comes from.
That's the magic combination. And the results are pretty staggering. The source quotes build times like, in just about 4 seconds, I have a production build created.
4 seconds. For a production build.
Right. And a development build in just 2 seconds. For anyone who's waited minutes for Veng serve to start or Veng build to finish on a big app, that's, well, revolutionary.
That's going to make a lot of developers very happy.
Immensely. It drastically improves developer experience, especially on large applications. Faster feedback loops, less waiting, more time actually coding. It's a massive productivity boost.
Are there other benefits besides just speed?
Definitely. Vite brings modern ES module support natively, which is great for how JavaScript modules talk to each other, especially important when you get into remote modules like with micro frontends.
Okay.
The faster build times also directly translate to lower costs for CI/CD, continuous integration, continuous deployment. Those build servers in the cloud cost money per minute, right? Faster builds mean lower bills.
Ah, a tangible cost saving too.
Yeah. And Vite also has integrated server-side rendering, SSR support, which is great for performance and SEO.
And is it hard to switch over?
Apparently not too bad. The source mentions it's mostly updating your angular.json to use the new Vite-based builder instead of the old one. A pretty clear sign Angular is committed to leveraging the best tooling out there.
Wow. Faster builds, lower costs, better DX. That's a compelling package.
It really is a significant step forward for the ecosystem.
Okay, so we've built our app, maybe using a hybrid approach, lazy loading, and now super fast Vite builds. But what about sharing code? In a big company, you might have lots of apps needing the same UI components or logic. That's where Angular libraries come in, right?
Exactly. Libraries are how you package up reusable codebases.
How do you structure those? Is it different from building an app?
The workspace structure is similar. You still have your angular.json at the root managing everything. Inside a projects folder, you'll have your actual library, code, the components, services, etc. you want to share.
Okay.
And the source strongly recommends having a demo app right there in the same workspace.
A demo app, just to show how to use the library.
Partly, but it's also invaluable for development. You can run the demo app locally and interact with your library components as you build them. It's like your first customer, helping you test and refine the library's API and functionality.
Makes sense, like a local testbed.
Precisely. The source also mentions using NTM scopes, like at PS in their Pluralsight example. That's standard practice for organizing packages, like at Angular for Angular's own stuff. Using your company's scope, like at my company Commonwe, helps keep things organized and avoids naming conflicts.
Okay, so we have the library code and a demo app. How do we actually package it up so someone else can npm install it? The source mentions ngpackage.
Right. ngpackage is the go-to build tool for Angular libraries. It's specifically designed for this. Its main job is to make sure your library follows the official Angular package format.
There's a specific format.
Oh, yeah. A detailed specification for how libraries should be compiled and structured to ensure they work correctly with different Angular versions. Build tools like Webpack or Vite ES modules, it guarantees compatibility. ngpackage handles all that complexity for you.
So it takes your library code and bundles it correctly.
Exactly. It uses a config file, usually ang-package.json inside your libraries folder. This file tells it things like where to output the built library, the dist folder, and crucially points to an entry file, almost always called public ap.ts.
Public ab.ts. What does that do?
That file is key. It defines the public face of your library. Whatever you export from public ap.ts is what consumers of your library can actually import and use. Anything not exported from there is considered internal, private implementation detail.
Ah, so it controls the library's public interface.
Precisely. It enforces encapsulation at the library level.
And building it is easy.
Super easy with the Angular CLI. Just build your library name. ngpackage does its thing, puts the ready-to-publish package in the dist folder. Then you just seed into that folder and npm publish. Done.
That does sound straightforward. But the source mentions something more advanced. Multiple entry points, like a library within a library. What's that about?
Yeah, this is a really powerful pattern for larger libraries. So your main public application ES defines the root entry point, import, from at my company melib.
Okay, the default way.
Right. But multiple entry points let you define sub-entry points. Maybe you have a big UI library. You could structure it so users can import everything from the root, or they could import just the button stuff, like import button from at my company me lib button, or just the modal stuff, import modal from at my company me lib modal.
Ah, so consumers don't have to pull in the entire library if they only need one piece.
Exactly. That's the huge benefit. It allows clients to only consume the bits and pieces they actually need. This can drastically reduce their application's bundle size and improve performance, especially if your library is large.
That makes a ton of sense for performance optimization.
It does. It encourages you to structure your library logically, maybe by feature or component type. At my libcharts, at my libforms, at my libutils. It gives consumers fine-grained control over dependencies.
Very cool. Now, a related question. Can these Angular libraries export web components? The framework-agnostic standard components.
Interesting point the source addresses. You can definitely create web components from Angular components using a feature called Angular Elements. There's a create custom element function for that.
Okay, so you can wrap an Angular component as a web component.
Yes, and that web component can then be used anywhere, React, Vue, plain HTML, whatever. It's great for interoperability. However, the source clarifies that packaging and distributing these via a standard Angular library built with ngpackager isn't quite as seamless. The web example in the source is actually built as an application, not a library.
Why an application?
Because currently, there's no way to generate an Angular component library that exposes a web component directly through the standard library build process in the same way you'd export a normal Angular component.
Ah, a limitation in the tooling then.
Sort of. But here's where the new Vite builder comes back in handy. When you build that WebScape variation with Vite, it can output a single self-contained bundle, like one main.js file.
And that bundle contains the web component.
Exactly. And then any other application, Angular or not, can just include that single script src main.js tag, and boom, the web component is available to use.
So it bypasses the typical library install process, but still makes it easy to distribute and consume the web component.
Precisely. It's a very practical workaround using the application builder to achieve that framework-agnostic distribution for Angular-authored web components. A clever use of the tools.
Okay, that clarifies the web component angle. Now let's zoom out again to those truly massive applications. Multiple teams, maybe hundreds of developers. The complexity just skyrockets.
The monolith starts to break down.
Right. So what are the big strategies the source introduces for managing this level of scale, these large-scale Angular app concepts?
This is where we get into the really heavyweight architectural patterns. The source focuses on three key, often interconnected concepts for managing this complexity: micro frontends, module federation, and monorepo integration, particularly using an X.
Okay, three big ones. Let's start with micro front-end architecture. The name suggests splitting things up, right? How does that actually simplify things?
It's more strategic than just splitting. Micro frontends involve decomposing a large front-end application into several smaller, independently deployable applications.
Independently deployable. That sounds key.
It is. Imagine that huge e-commerce site again. Instead of one giant front-end code base, you might have separate apps for product catalog, shopping cart, checkout, user accounts, maybe an admin dashboard. Each one is a micro front-end.
And different teams could own each one.
Exactly. That's the core idea. The catalog team works on the catalog app, the checkout team on the checkout app. They can develop, test, and deploy their piece independently. The user sees a unified experience because there's usually a thin shell application that orchestrates and wraps these smaller apps.
So the simplification comes from smaller code bases and team autonomy.
Precisely. It breaks the monolithic bottleneck. Teams aren't constantly stepping on each other's toes in one massive code base. They have ownership, move faster, and the blast radius, if something breaks, is smaller. It affects their micro front end, not necessarily the entire site. As the source says, it can help you simplify large applications by reducing cognitive load and enabling organizational scaling.
Okay, splitting into independent apps makes sense organizationally, but how do they technically come together for the user? If they're deployed separately, how does the shell load them? That's where module federation comes in.
Exactly. Module federation is the technical enabler for dynamically composing these micro frontends at runtime. It's a technique popularized by Webpack that lets a host application, the shell, dynamically load in other apps at runtime.
Dynamically, so not at build time.
Correct. And crucially, those other apps or micro frontends can be hosted elsewhere on different servers, different URLs. The host just needs to know where to find them. This enables true independent deployment.
Wow. How does that work under the hood?
It leverages Webpack's Module Federation plugin. There are configurations on both sides. The remote app, say the Basket micro frontend, uses the plugin to define what it exposes, typically its main Angular module, like Basket module.
Okay, it declares what it's sharing.
Right. And very importantly, it uses the shared configuration to specify dependencies like Angular itself, RxJS, common libraries, that it expects the host to provide.
To avoid duplication.
Exactly. So you don't load Angular 17 5 times if you have 5 micro frontends. The host provides it once, and the remotes share that instance. Huge for performance.
Makes sense. And the host side.
The host app, the shell, configures the plugin with the remote's object. This maps a logical name, like a moo basket, to the actual URL where the remote app's entry point, remoteentry.js, can be found, like mfab-basket, http://localhost.4201 remoteentry.js.
And the host knows where to fetch the remotes from.
Yep. And then integrating with Angular's router is surprisingly smooth. You can use load children, just like for regular lazy loading, but point it to the remote module name, like load children. Import Momfa basket module. Module federation handles the dynamic fetching and loading behind the scenes.
That sounds pretty elegant.
It is. There's a little TypeScript helper needed usually just to declare the remote module type so your IDE doesn't complain, but functionally it integrates very well.
In development, How do you run all these separate apps together locally?
The source highlights the Module Federation dev server, which is brilliant. It can read your configs and automatically start the shell and all the defined remote micro frontends on different ports. So you run the shell, navigate to the basket route, and you see the network request going off to localhost spont 4201 to fetch the basket code dynamically. It makes local dev feel seamless.
Okay, micro frontends for decomposition, module federation for dynamic loading. But managing all those separate apps and libraries, even if they're independent, sounds like it could still be a headache. Versioning, dependencies, refactoring across them.
You've hit on the next crucial piece, the organizational structure. This is where monorepos, especially with tools like Nex, become invaluable.
Monorepo, everything in one giant repository.
Essentially, yes. A single Git repository containing multiple projects, your shell app, all your micro front-end apps, all your shared libraries, maybe even back-end services. And the source strongly recommends Nex because it probably has the best integration with Angular.
Why is putting everything in one repo better for this setup?
Several huge advantages for large-scale projects. First, large-scale refactoring becomes much, much easier. Need to change an interface used by 10 micro frontends and 5 libraries.
Oof. Sounds scary across separate repos.
Exactly. In a monorepo, you make the change across all affected projects in a single atomic commit. You can run tests across everything impacted to ensure you didn't break anything. It massively reduces the risk and effort of large refactors.
Okay, that's a big win. What else?
More effective code sharing. In separate repos, communication breaks down, code gets duplicated. In a monorepo, everything is visible, discoverable. It naturally encourages reuse. NX even helps visualize the dependency graph between your projects.
It's easier to see how things connect?
Yep. Also, CI/CD can be simpler and more efficient. You have unified build and test commands. NetX is smart too. It can figure out which projects were actually affected by a change and only build and test those, saving tons of time and compute resources in your pipelines.
Intelligent builds. Nice.
And critically, monorepos pair well with micro frontends and module federation. Having everything in one place makes it much easier to build and deploy them together, even though they run independently. You can easily convert an existing Angular workspace to Nex.
Does module federation still work inside Nex?
It does. The source mentions maybe needing a few minor path adjustments in the Webpack configs, but the core mechanism works fine. NX uses project.json files in each project folder to define targets like build, serve, test. The serve target for your micro frontend apps just points to those custom Webpack configs using module federation.
So Nex orchestrates running the federated apps.
Exactly. You can run xserve shell mefbasket, and NX spins up both apps on their correct ports, all managed from the single repo. It provides that essential structure and tooling layer on top.
Wow. So micro frontends, module federation, and Nex monorepos. It sounds like they really work together powerfully.
It's definitely a synergistic effect. Micro frontends give you the decomposition and team autonomy. Module federation provides the dynamic runtime integration. And the Nex monorepo gives you the unified development environment, tooling, and management capabilities to handle it all effectively. You get easier local dev, easier testing, more efficient CI/CD, all while enabling that great separation of concerns needed for truly large-scale multi-team development. It's really the modern blueprint for tackling that massive application complexity.
That's an incredibly comprehensive picture. We've gone from the absolute basics of Angular modules, components, services, all the way through modern choices like standalone components and hybrid approaches.
Lazy loading, the speed boost from Vite.
Right.
Yep.
And then into architecting reusable libraries with in-packager and multiple entry points, and finally landing on this powerful combination of micro frontends, module federation, and Nex monorepos for tackling truly enterprise-scale complexity. It's been quite a journey.
It really covers the spectrum of modern Angular architecture. And if you look at the bigger picture, it's all about enabling developers to build applications that aren't just feature-rich, but are fundamentally maintainable, scalable, and performant.
Keeping things simple, even when they're complex underneath.
Exactly that. Making those deliberate architectural choices to manage complexity, rather than letting it manage you. Building systems that can evolve and adapt.
So for you listening, what really stood out? Was it the idea of that hybrid module standalone strategy? Or maybe the sheer speed of Vite builds finally solving that build time pain point?
Or perhaps it was seeing how micro frontends and monorepos provide concrete solutions for scaling not just the code, but the development teams themselves.
Lots to think about, which naturally leads to a final thought. Given how rapidly things change, how might Angular continue to evolve? What's the next step in making it even easier to build these massive distributed global scale applications?
That's the big question, isn't it? How do we push the boundaries of simplicity and scalability even further?
A question for the future, perhaps. For today, thanks so much for joining us on this deep dive into Angular architecture for scale. Until next time, keep learning, keep building, and keep making those smart architectural choices.